use push to talk. That's what I use. I'm going to need to turn push to talk off though, because I'm going to be typing and kind of explaining me doing things as I'm going along. So, but please mute yourself if you can, or use push to talk. Either one is just fine, and we'll get it started. Yeah, if you want to see my stream, you should just be able to click join stream on my name.
Yeah, apparently there's a max limit on that. Some of our other team members can't
like
view.
50 or something.
Yeah. All right, hang on a second. One sec. Did not know that, so I'm going to then stream to Twitch, so you'll be able to see me on Twitch, so give me a minute.
I think you could boost boost the server, and you might be able to get more.
Server's boosted to full, unfortunately. There must be a max you can do.
Yeah, it states that I've joined, but I've only gotten one frame and the spinning of doom.
And I'm a single co-parent. My kids are with me half the time. That's it. You know, I have to balance all of these things. And
I muted that person.
Whoa.
I took care of it. All right. We can get started. So everybody can see me on my Twitch stream, correct?
What is your Twitch stream?
It's just twitch.tv/hackingdave.
Again?
Twitch.tv/hackingdave. Everybody sees it?
Correct. Yeah, it was fine.
Great. Okay, give me 2 seconds. I'm just going to post it on Twitter really fast. All right. It's amazing what a eGPU can push out on Twitch and on Discord, and holding 700 people, I think, in a Discord channel. So, yeah, I can disable that beep. Let me disable that 1 second. Actually, you can disable it in your settings. I can't disable it in mine. It's under notifications. All right, we'll get started. So, hey, I appreciate everybody coming on, and this is our first Discord hangout. So if things go horribly awry or wrong, we'll definitely tweak it for next time. We didn't know that there was a 50 limit on what you can stream live on Discord, and we've well surpassed it. It looks like there's several hundred people, so that's awesome. And we also got a lot of people on Twitch. So we'll kind of go through and doing that. So if you're listening, head to twitch.com/hackingdave, and you can see all this streaming live here. Let me just switch really quick from push to talk, and I will get started. All right, that should do it. Let me just make sure I'm lighting up here. Can everybody hear me still? Okay, cool, perfect. All right, let's get started. So what I'd like to do first is give a little bit of an introduction around what we're going to accomplish today, and then go into and dive into AMSI, as well as talk about Windows Defender specifically and its several layers of protection. So when you look at what we're going to be kind of demoing today, I'm going to show you just as an example of Magic Unicorn and getting familiar with the ins and outs of that, how to rewrite it, how to get around the detections. But I also want to show you how you can do it in your own code and things that are on the net, not just specific to Unicorn. So we're also going to go and rewrite Rastamouse's AMSI bypass, which currently gets picked up. And it actually has some pretty good detections from Windows Defender on it. So we're going to rewrite that as well as part of this. And then we're going to incorporate all of that into an attack that's going to get around AMSI. But then we're going to see that there's going to be a second level of protection that Windows has in Defender, which is used for scanning memory space for specific pieces of shellcode. So we're going to do a second stage to get around that as well. So we're going to get around AMSI. We're gonna first rewrite our own code to get around AMSI. Then we're gonna rewrite Rastamouse to get around to put in AMSI bypass, just as an added cool factor to show different tools out there. And then we're going to look at what's happening afterwards and why we still see the behavior that we exhibit in Windows Defender. So it'll be a lot of fun. We'll go through how all this works here and kind of give you a little bit of understanding around how this works specifically in Windows and how you can redo your tooling to get around AMSI and Windows Defender specifically. So in this specific case, if you see in the screen here on the right-hand side, well, it's on my right-hand side, not yours. The way AMSI works is essentially whenever you start an application, let's just say it's PowerShell or any type of scripting language, AMSI.dll is going to be injected into that process memory space. And then there's essentially a hook that's going to happen right before the actual code is about to execute. And it's going to submit it to either AMSI scan string or AMSI scan buffer, which are two of the main APIs that are used within Windows Defender. From there, and this, by the way, this graph is from Microsoft's website. I want to caveat that. From there, what will happen is, if you're using things like PowerShell with encoded command, it will be already decoded in that sense, and it'll be basically ready to execute directly with the PowerShell interpreter, but it's going to scan with AMSI scan string first to go directly to the whatever engine, antivirus engine is subscribed to the AMSI providers. And so in this case, we're going to be using Windows Defender, but there are definitely things to note that there are other antivirus products out there and EDR products that subscribe to AMSI as well. And so what will happen is it'll take our code, and our code will be submitted directly to Windows Defender, and then Windows Defender will essentially do a signature check against that in memory, as it's happening prior to it actually executing. In the event that it gets detected, it'll return an error message back saying this has been detected, this script is malicious, it's going to block that content, and it's not going to allow it to work. So in this specific case with Magic Unicorn, just to give you a little bit of history around Unicorn, it's a tool that I wrote a number of years ago, I think around 6 years ago, and a little bit of history lesson in PowerShell too, I guess. I gave the very first ever PowerShell security talk with another individual named Josh Kelly. And back then, we started talking about when PowerShell Beta was first coming out, Microsoft was talking about integrating it into their operating systems. And we had raised some alarms and said, well, if you give a full-fledged programming language, into Windows that is as powerful as what we're seeing for PowerShell, it could absolutely be used, from an attacker's perspective, and be used, to go after organizations from a programming perspective. And interesting enough, that came to fruition. We saw the kind of the PowerShell security research, wing kind of funnel out of that talk and kind of go forward from there. And we've seen PowerShell as a very big attack surface, for most organizations. Now, I would say from a red teaming perspective, if you're going into a company that is decent in nature, that has some good detections in place, PowerShell can be one of those things where you may want to skip to something different to do better evasion. But in most cases, PowerShell still works very well in most organizations that's out there. And PowerShell, from a security perspective, if implemented properly, is probably one of the most secure programming languages out there. But what's interesting about what's kind of happened with the industry around security is, Windows Defender really hasn't gotten much better when it comes to identifying or figuring out what signatures are kind of happening out there. It's still very much a signature-based driven tool, and I'll show some of this here. It's they do talk about some sort of behavior-based analytics and things like that. I really haven't seen it. It's really about figuring out the understanding around. Here, I'm just going to mute somebody real quick. 1 second. There we go. It's really about understanding what the signature is and manipulating your data in order to get around that signature. And so when we look at what we're going to be doing today, Unicorn, I wrote 6 years ago. About 3 years ago, it had been gaining a lot more and more popularity as an exploitation framework for PowerShell. And so Windows started writing signatures for it. And so I started having to write bypasses for it back and forth, and it's basically been a back and forth, ever since then, on writing specific types of bypasses to get around it. And it's usually very, very trivial to go and do, and I'll show you some of the examples here in a second. But what's interesting about Windows Defender or any type of antivirus product when it comes to signature-based detection is you just have to figure out at what spot is it being picked up at, and AMSI is no different. AMSI is very weak in the sense of you only have to change or manipulate the strings that are being flagged by the Defender signature in order to get around AMSI. It's not going to actually assemble all of that code. So string concatenations, things like that are all valid ways of getting around it. Rename function types, splitting your code up. All of those things are things that we can use to get around AMSI because it doesn't, again, assemble that entire code itself. It just scans what's about to be executed into PowerShell. Now, again, we'll talk a little bit about a secondary mechanism that's built into Windows Defender that scans memory space that we'll have to get around in this case because our shellcode is going to be picked up. So we'll go through some of those different scenarios as we kind of go along. But let's start off with Unicorn in the first place. So I'm just going to go ahead and run the Pentesters framework. And if you're not familiar with that, it's a tool that I wrote that pretty much has whatever tools you can possibly imagine in it, over 308 tools. In there, you can do a search for whatever tool you want to. So if you want to install Metasploit, you can install Metasploit. And the reason why these show up is that they have dependencies of Metasploit in them. But you can go ahead and just install whatever tool you want to, and it automatically automates a lot of your different areas around there. Got it. Next time, I think I'll just mute the whole. Actually, I think I can mute the whole room. That's fine. We'll do it later. So then, what we can do here is I'm going to search for Unicorn. And I'm going to go ahead and install it really fast. So we're going to install the latest version that is up on the site itself. So this is going to run through, and it's going to automatically install Metasploit for me since part of Unicorn, it'll leverage the Metasploit framework if you want it to. You don't have to generate interpreter shellcode or any shellcode based off of Unicorn itself. But you can import your own. Let me find another one. Hold on. Here, I'm just going to go ahead and remove the channel permissions for anybody to talk. How's that? Give me 1 second here. There. That should fix that. Can everybody still hear me? All right. I just dropped the voice channel. No one can talk anymore in the voice. So we should be good. Sorry about that. All right. So what we did, what this will, you don't have to use Metasploit as a framework to bring in your shellcode. You can bring in your own custom shellcode. You can bring in Cobalt Strike shellcode. You can bring in anything you want to. So it doesn't have to be specifically Metasploit. And there's some pros and cons to that. Metasploit's just like any other tool that's open source and public. There is a number of signatures and detections built off of it, so you really have to customize your code and go around it as you're going through everything. So it really just depends on what you want to accomplish out of Metasploit itself and how much effort you want to put into it. But other tools, your own shellcode, all that stuff works great. So now that we have this installed, we're going to go to Pentest Post Exploitation Unicorn. And here we have our initial files. There's no dependencies for Unicorn itself as far as having to install any requirements or anything like that. It's all native. It runs in Python 3. And basically what we're going to do here is we're going to go ahead and run it. Let me just get pulled real quick. 1 second. I was messing around with it earlier, that's why. Okay, so we're going to go ahead and run Unicorn. And here we have all the syntax that we can do. Now, I'm going to go ahead and run a reverse shell. So the example here would be right there. So, Python, unicorn.py, Windows interpreter, reverse HTTPS, and then your IP address and your port that you're going to go and run on. And this is all live, so demo gods are totally fine. I sacrificed some animals outside beforehand. But we can also do things like create our own macro version too. So we can create and download executables. Like one of these payloads is Windows download and exec. It'll download a specific payload and embed that into the macro. All right, hang on a second. Sorry, okay, I got it. Just checking. Okay, just making sure everybody's still muted. Cool. So then we can also embed it into an HTA file. It'll create HTA files for you. You can embed your own shellcode into there. It has a lot of different options available. You can import your own Cobalt Strike file, and it'll embed these in macros too. So when you embed the macro in, as soon as they hit enable macro, it'll enable it and then do code execution through PowerShell. And then execute on the system itself. Ooh, I've had a typo in there forever. I wonder, man, that's a bummer. I have to fix that later. And so when we're going to generate this, we're going to run Python, unicorn, and then we're going to type in our IP address, and we're going to generate our code, okay? All right, so we're going to have it generate on 140 to our back IP address, and then we're going to have it connect back to 443, which is going to be where we're going to have our listener at. But we're not going to even set up our listener now because I'll just give you a heads up. It's not going to go well. It's going to get picked up by AMSI, and I'm going to bring in my Smalltron editor here really fast, and I'm going to go ahead and run. I'm going to copy this over real quick. So here we have our code. Now I want to show you a couple things really fast. I got a lot to cover in a short period of time. So what we're going to be doing here is running this code, and this is essentially with encoded command. You can take your code, you can cast it Unicode, base64 encode it, and then you can essentially get around what are called execution restriction policies, which there are all signed, remote signed, unrestricted, restricted, and not a lot of people use these because they're very easily circumventable. Better options are things like constrained language mode and things like that. But in this specific case, we use toString and get value to reassemble encoded command so that we're never actually calling encoded command in the first place. And also, by the way, I'm going to offend most people out there. I use Nano and VI sucks. So just an FYI for any VI users out there, you're using a very antiquated and old bearded editor. So just throwing that out there. Just messing with you. I'm kidding. You can use whatever you want to. But anyways, so you can, in this case, we use what's called toString, which will reassemble encoded command for us. So you can see here encoded command is actually being passed right there, and it's just the abbreviated encoded command EC. And then from there, what we do is we basically reassemble the encoded command parameter through here and then call our encoded command. Now there's some things that happen in between here. We actually chunk up the code a little bit randomly throughout the string so that if people are trying to look for things like base64 encoding, it kind of throws them off a little bit because they're not doing string concatenations to reassemble those. And so it kind of throws everything off as we're kind of going along here. Now I want to show you what this code looks like decoded, okay? Because that's what we're going to be playing with in this specific case. Now there's a couple of ways that you can get to this decoded code. One is I can just edit this PowerShell tags file. And I'm just going to take the first part off because I don't care about this, and I just care about the encoded code itself. Let's go ahead and get rid of some of those concatenations happening in here, and let's get rid of that. We're going to say A equals, and we're just going to have our data here, and then we're going to import base64, and then we're going to print base64.base64 decode A, and this is going to print out our decoded code here in a second, okay? Notice I didn't have to type in 17 different commands to exit VI at that time because I was using Nano. And what we're going to do here is just going to run this command. Just run PowerShell, Python PowerShell attack.txt. And this is going to get us our decoded code right here, okay? What you could also do is you can go into unicorn.py, and if you go down here really fast, go down to the section here, you can also just turn print decoded to on, and this will automatically decode the unicorn code directly for you. So that's just a feature that if you don't want to do the base64 decoding, you want to get to the code itself, you can just go through that, okay? But in this case, we're just going to copy this code right here. All right, so we have our code here, and this is the unicorn code itself. What we're doing first is we're importing in specific DLLs because we need specific calls to be able to do our process injection, to allocate memory and to inject into that process space, which are going to be injecting into PowerShell. What this also does, by the way, is it uses what's called a syswall64 downgrade attack, which is something that I figured out a number of years ago. But when I wanted to attack a system, I didn't know if I was going to be in a 32 or 64-bit platform. And that's important to note because I have to use 32-bit shellcode in a 32-bit platform and 64-bit shellcode in a 64-bit platform. And what I did is I first profile the system itself to see whether or not I'm in a 64 32-bit platform. I do that down here. So, if 64-bit is equal to, the operating system, then, use syswall64, which is going to be the 32-bit compatibility files inside of Windows. So if you go to // Windows / syswall64 / Windows PowerShell / version 1.0 / PowerShell.exe, that will be a 32-bit native binary inside every 32-bit platform. I'm sorry, every 64-bit platform. And so what will happen is that I can use native 32-bit shellcode directly in Unicorn itself. So it allows me to go ahead and be cross-compatible with both 32 and 64-bit. Now, in this specific case here, there's a number of things kind of happening. One is we're going to create a thread, but we're going to be under the context of the PowerShell process. So if you're looking at this from a parent-child process relationship, you'll actually see, if you're in a 64-bit platform, you'll see a 64-bit PowerShell exe from the System32 directory kick off, but you also see a syswall64 child process kick in that place. So if you're looking for that within your detection capabilities, that's definitely something to take a look at. What I usually do when I'm going after Unicorn is I'll remove the syswall64 component, and I'll just do 64-bit shellcode injection, because most people are still using, most companies are using 64-bit operating systems in the first place. And so in this case here, we also do some string obfuscation. So what will happen with AMSI is if you're just using interpreter and you're grabbing shellcode, whether it's Shikata, it'll or Shikata Guy Nay or any of those other ones, it's going to pick those up because there are static profiles in the shellcode that Windows Defender picks up in the first place. So what we do is we do string substitutions here, and every time this will change. It could be a semicolon, it could be other strings. It basically randomizes the data set throughout here as we're going along, and then we do a replacement right down here. So we replace that with a 0, it ends up being a 0x, and then we basically split that into a data stream that we can then use for our shellcode that's going to be executed on the system itself. So what will happen is when this runs, we import our DLLs that we need in order to call the function types. We are then going to inject into our process memory space with our shellcode, and then we're going to execute that shellcode either in the syswall64 space, or if we're using a 32-bit mode, in the normal System32 directory. It's also going to use a very well-known method called invoke expression, or IEX, to get code execution on the system itself through what we're calling in this specific variable here. And so let's go ahead and run this really quick, and we're going to see what actually happens as we go through and do this. So we're going to open up PowerShell. I'm going to do everything in the interpreter, just as an example. I'll probably increase my font size. That's not too bad. Okay, so we have our code here. What we're going to do now is we're going to go ahead and hit play. Now notice when we hit play, it says this script contains malicious content has been blocked by the antivirus software. So we are getting hit by AMSI. Remember, AMSI is that DLL that gets injected into our memory space that is now hooking and looking at what we're going to be executing prior to actual execution. So this is pre-execution detection, okay? We're not actually executing, even though it's all in memory and we're executing it, we haven't fully executed the code itself yet. It inspects it first to determine whether or not it's there. Again, it's submitting it to Defender through the AMSI scan buffer, and then that's going to return the value whether or not it's being detected or not. So there's a couple of options we have at this point. One is we could use an AMSI bypass, which there are a number of those out. Rastamouse is probably my most favorite, the most recent one that I recommend using. There's one from CyberArk that did one for injecting the entire old DLL into memory that you could then call and turn off the specific functions of AMSI. So there's a number of different ways to look at disabling this. So you can go that route, or we can take a look at what's actually flagging in Windows Defender. Now, this part is a little bit tedious, because what you kind of have to do, and I made it easier for myself, and I haven't released it yet, but I probably will soon, is, I like to break things out a little bit. So I'll start to break some of this code out a little bit here, just to kind of get a look at it. So, after every like little semicolon here, you might just break this out a little bit to make the code a little bit more readable, since it's not just on one line. So let's just go ahead and do this a little bit. We'll go through, kind of cut through some of the code, and kind of bring it into a more readable format for us. It doesn't need to be perfect. I might miss a couple of these. Doesn't really matter. And what we can do is we can start to look at what spots in the code AMSI is flagging on, and kind of home in on the different areas that there might be. So, you know, this is one section here. Actually, it's one section here. Sorry, I forgot a couple. So I kind of like to break this up into sections of what's happening. So this is our shellcode up here, so we can break this out a little bit. We can break this out a little bit. Let's go ahead and break this out a little bit more. So we're just kind of breaking this up, making it a little more readable for us as humans. Computers don't care. So that should be good. Okay, so we have really 3 chunks of code that we want to look at. Now, when we're looking at syntax here, what we want to do is kind of look at the code and see what part of it is getting flagged. Is it this code here? Is it this code here? Is it this code here? And let's start to look through that to see whether or not, you know, we're getting flagged by something in here. Now, let me break this up just a little bit more. In my code, since I know my code a little bit better than most, I would say, we can basically delete all this and check it out. We can delete all this and check it out. I'm going to go ahead and just delete this part here, okay, and see what happens. All right, so let's go ahead and do that. And actually, I don't have to delete it. I can just highlight this and copy it over. So we'll copy this over, and we'll paste what we just did here, and we'll hit play. Now there's a parser error, which means I need to, 1 second. There's a single quote here somewhere that I'm missing. Da, da, da. 1 second, it's here somewhere. Here it is. That's what I'm missing right there. A little single quote there. So what we can do is just put a single quote here and close that up. That's not what I wanted to do. All right, notice here that it works, right? So we know that it's the bottom part of our code. So let's remove this thing real quick here. So somewhere between here and here, we need to chunk up our code a little bit more to figure out what's actually happening. Now, since we don't have a substantial amount of time to go through all this, I'm not going to go through each and every one to show you. But what I would do is just remove a few of these at a time and see which ones you know, are flagging and what's not. Now, knowing Microsoft, and I've already done this demo ahead of time just to prepare for it, is I know that they're going to be flagging in this area. This is the for some reason, this is the area that they always focus on for me. This one specific parameter, so or variable. So somewhere in here, hang on a second, server. Hang on a second. One second. All right, so right here, we're gonna go ahead and modify and change some of these parameters here. Now, to put it in perspective, we don't need this int here. The reason the int was there in the first place was just changing that got it around the last AMSI thing. I'm telling you that the way to get around this is just figuring out where your code is at and then changing what their signature is looking for, right? So their signature is somewhere in the ballpark of if virtual protect and integer of, and this number, by the way, changes all the time. So it's not based off this number. So I'm guessing an integer of 4. And it also has a 40 in there and maybe a ref in there for reflective. You know, you're going to basically trigger a specific detection on viruses. So what we can do here is we can do a few different things to see if this will get around AMSI. So first, let's go ahead and look at this and say, okay, let's break this out just a little bit. So let's take test equals int 0x1007. And let's go ahead and put test here. Okay? Now we're rewriting that string, right? And again, AMSI doesn't do any reference checking on what does test actually do and substitute test in there for integer of 1007. It only looks at does this match the original signature that had in place? Does it have an int, 1007 in comparison to maybe a 40, maybe whatever we're looking for from a virtual protect perspective. So again, the way that we're looking at this is we're comparing, or we're changing it to break up that signature that they have in the first place. So let's go ahead and copy this over. And we'll go ahead and hit play. And notice here, it executes. Now notice here on the right-hand side, we just saw virus and threat protection detected. Now I'm going to explain this here in a second. So what we just did right now is we got around AMSI. So now we're living in the post execution space. So we're now around AMSI. So we've gotten completely around the anti-malware scan interface at this point, just by rewriting this specific area. Now, conversely, when I see some other giggles, watch this. You can also just do int, and that also gets around AMSI. Again, you're breaking their strings for static signatures. So let's go through that. And again, this is post-execution. It executes, but now we're seeing here that the execution is being stopped. So this is the secondary part of protection that we have to get around here, okay? Now, here's what's happening. So AMSI says, hey, you're good because you got around their detection. It is not heuristic. It is 100% signature detection. And so we're at the secondary phase of Windows Defender, which is now where it actually goes in and it scans your memory space. Now, when you're scanning your memory space, there are certain considerations you have to do. It's going to look for certain things. It's not going to care about this code here. It's not going to care about this code here. But what it is going to see is this already substituted, and it's going to see the shellcode. So let's go look at the logs really quick on this from an event viewer perspective. So let's go into Windows. We're going to go to Application Service Logs. We're going to go to Microsoft. We're going to go to the anti-malware, Windows. And we're going to go into Windows Defender. And then we're going to click on the operational log. And we're going to see here in this specific one, notice Windows Defender Antivirus has taken action to protect this machine from malware and other potential. Now here's the name behavior Win32 interpreter. Now I want to be very clear. There is zero behavior happening in this at all. There is no behavior detection happening whatsoever in this specific detection. They just use that term because it's kind of an enhanced way of scanning memory. There's no analytics or behavior detection occurring in this specific part. They're not saying, okay, well, PowerShell spawning a child process of PowerShell that's in the syswall64 directory and now kicking off shellcode. That would be more behavior detection. What they're doing here is they're scanning the memory space of where you're at and looking for static signatures of shellcode. So the problem with something like Metasploit, obviously, is that our shellcode needs to be written in a way that gets around hard-coded signatures in memory that are shellcode specific. Now, there's a lot of ways of doing this. Now, before I get into going into this area here, I'm going to show you really fast one of the tools that I wrote that helps me find where these specific patterns are. And again, I may eventually release this. I haven't decided, but let me go to my new version of Unicorn that I'll be releasing right after this talk. And okay, so this is my new version of Unicorn, which I'll be releasing here shortly. And this new version of Unicorn has has now incorporated Rasta's AMSI that fully gets around both AMSI and Windows Defender. And so you can just incorporate the AMSI bypass directly into it. So this new version will have that into it. It also adds better invasion to get around the latest detections that were put into Windows Defender as well. And I also added when you turn AMSI bypass will now be on by default, and it'll create two-staged things for you. Let me show you really quick. So now it'll create two-staged PowerShell commands for you to run. One being the AMSI bypass, and the second being the actual Unicorn payload, so you don't have to actually go through and do the AMSI bypasses on Unicorn if they write new signatures for it. So that'll be incorporated into the new version of Unicorn that I'll be releasing right after this, as soon as we get done with this. So what we're going to do, I wanted to show you one of the tools that I wrote that helps me do a lot of this analysis. And you can do something very similarly. So this is called Number 2. I'm a huge Star Trek fan. But what this is going to do is it's going to actually submit my code directly through AMSI to see if it gets detected. Here we see it's getting detected. It's actually chunking up my code for me and analyzing it to see which part of the code is actually being executed or being detected by Windows Defender. And then it's going to return back eventually that value that's actually being used. Since I'm using an old version, I piped it to my post-exploitation old version. And now notice here, it just found the identified block for detection. And here's a section that we needed to rewrite. And that's the section that we originally generated before that we created. So you can see here, now I know where to go to rewrite my section to get around AMSI in that specific case. So again, you just tools that you make to make things easier for you, as you're going through a lot, going in through. And I'm not aware of an online AMSI service. I'm submitting it directly to my Windows machine through file shares, essentially, and then running a command on it to see whether or not it's being picked up by the antivirus interface. You can also use Cobber has a let me see. Hang on a second. Cobber has the AMSI PS AMSI, which is really cool. So PS AMSI, and I'll pop it in the chat room for you. You can use that to return true or false values on if you're being detected, if your specific piece of code is being detected within AMSI. So that also can help you automate that. I don't use that one specifically, but I have used it before in the past, and it works fantastic. It's a great resource. So that's one way of detecting it, or finding out where you're being detected specifically. So I want to show you an example here, and this is a Metasploit example, and I'm going to go ahead and run Metasploit, but I'm going to use the encryption side of it, and I'm going to export it as PowerShell. So what we're going to do is we're going to load MSF Venom, and then we're going to create a interpreter shell via the reverse HTTPS, just as before. We're going to create a local host, local port, and then we're going to export it in PowerShell, but we're also going to use the encryption module. Now, the encryption module supports a number of different encryptions, including AES-256, RC4, etc., etc. With AES-256, you have to have a 32-bit initialization vector, or I'm sorry, cipher, and then a initialization vector that goes along with that. So it's just a little bit more of a pain, not a big deal. You can also use that as well. But the issue is it, even with using something like this, it still gets picked up by AMSI and also gets picked up by Windows Defender. So even using MSF Venom with the encrypt, you're not going to be able to get around this. So let's go ahead and run this really fast. So we're going to go ahead and export, we're just going to copy this. So this is the code that's being exported out through Metasploit. And we're going to go ahead and paste this into our Windows machine as well. AMSI does scan on every step, yes. Yes, it does. So then we're going to go ahead and hit play. Now notice here, we get picked up pretty much immediately with AMSI. And the problem, again, is going into that shellcode. Now, if I was to rewrite all this obfuscation, even with the encryption in place, we're still going to get picked up, unfortunately. Any type of Metasploit shellcode, by default, is using the payload.dll way to generate it. And that's what, unfortunately, once it's actually decrypted, once it runs in memory, that's what's actually being scanned. That's what you get used with. So we have to rewrite our shellcode in some way, shape, or form. So I'm going to show you an example here. Where I took some shellcode off of ExploitDB, which is just a message box as a proof of concept to show you what we're doing here. And so has Microsoft put a bounty head? I think they really dislike me, to be honest. I mean, not everybody there. There's some great folks at Microsoft. They're actually doing a really good job, and kudos to everybody there and their team. I'm just showing kind of the weaknesses of that and how you get better at it. But I definitely think that the people that write signatures for me probably do not like me very much. And I again apologize to you, but I'm trying to improve your product to get better than just doing signature-based detection. Okay, we're really trying to help out and making it go make it better. And you've gotten better over the years. It's time to get way better. So that's all. And so when we do this, we're gonna just show you if you have your own custom shellcode. And I'll give you some examples of how you do this here in a few. But what we can do here is we're going to run our same code as we ran before. And now notice down here, we have our bypass already in place, right? Our AMSI bypass that was getting hit before. We just put two integers in front, and put that bypass in so that AMSI won't flag on what we were looking at before. So we already have that built in here. And what we should see here is you're going to see that when we execute it first, we're going to get around the pre-execution phase. And then with our shellcode, we're going to get around our post-execution phase. Now, in this, all I had to do is, and here's how you put your own shellcode in if you want. And you can also just use the option to import your own shellcode into Unicorn. That's an option as well. But all I had to do was remember before this looked like kind of like this. Something like that. So it looked like that, right? All I did was I just took regular shellcode, formatted it properly with the 0x's in front, and I just pasted it in between those parameters here to get my new shellcode. These in place, what'll happen is it'll try to find and replace any of these. There won't be any, and it'll still split this into a binary array. So we won't have to worry about that in the first place. So you can just replace your own shellcode directly into those parameters here that you're going to be using in the first place. So again, what we should see is that we bypass AMSI, and we also get around the secondary scan execution because the shellcode is not in the signature database of Defender. So we should get around both protection mechanisms with how we go through here. Ha! No kidding, it worked yesterday. Hang on. Oh, I don't think I pasted the right code. Let me see. There it goes. Sorry, wrong code. So pasted it. Get our hello world. Our secondary issue works just fine. And our secondary detection gets fine. We get no detection up there. So again, using our own shellcode allows us to circumvent the detection criterias, secondary detection criterias built into Windows Defender. Now, you might be asking, how do I write my own shellcode? Well, there's some great resources already out there for doing all of this. There's one by Hacker House that shows on taking, so since Metasploit is all open source, you can take the code for payload.dll and you can write your own VB project and rewrite that portion. It's not hard, and it's actually really easy. Let me show you really fast. Here it is right here. And basically just changing up the specific read, write, execute memory sections, or adding different areas, you can easily do this right here. And there's the code samples right here to build it within Visual Studios, to build that project, and then import that into Metasploit to generate your own payloads. And then from there on out, you do not have to worry about getting detected with that shellcode moving forward. So I'd recommend spending, this takes 10 minutes, maybe 20 minutes to go through this and to be able to build this out and to use it from there on out just by changing those specific areas. And again, I'll keep this on the screen for a second for everybody to actually, I'll just post it in the Discord link for y'all. 1 second. Sorry, I know I move fast. A lot to go through. So that's a site for you to go to. There's also some other ones. There was just one released just recently within the past 2 days. That's a really cool command and control infrastructure that incorporates a lot of different techniques out there. And I'll post that here too. And so, using, again, your own shellcode and being able to build it out, building out your different sections, storing shellcode from a stage 1 perspective, this is a great resource to build that out too. So there are easy ways of being able to manipulate your own shellcode, to import your own shellcode, and not use something like Metasploit as your own. Now, again, changing Metasploit from its default that's out there is what I'd recommend when you're leveraging Metasploit in the first place. Interesting enough, Cobalt Strike does not get picked up, so that still works perfectly fine within Unicorn as importing that in as well. So as long as you're bypassing AMSI, you don't have to worry about the second stage detections that are happening in there. But again, some good resources for you to use if you're interested in doing that. So that's the two specific examples I wanted to show you. Now let's get into Rastamouse's bypass here really fast. And so let me get into that. Here we go. So with Rastamouse, fantastic person, by the way, really smart. Heavily recommend checking out his courses and the content he puts out. He's just a great person and a great researcher, shares a lot of his stuff. And this specific one here was released back in July of 2019, I think, was when it was released. 1 second. Getting a sip of water. And so here's the bypass here. And in this specific case, it's going to essentially disable, in that process space, AMSI. And obviously, it's copy and pasted from the internet, so it's going to have very specific detections in there. So I'll copy and paste this into the screen for everybody to see here. And so with this one specifically, what we can do with Unicorn is we can use this as our first stage, the send, and to essentially make the process AMSI free. We don't have to worry about AMSI injecting into our process space and running because it's going to be disabled. And so this is a lot less code to worry about than going through the Unicorn stuff. So let's take a look at this and what we can do to kind of manipulate and change this in some way, shape, or form. So let me get my example up here really fast. Now up here, we can already see some things that would be very specifically targeted by Windows Defender. Most specific hard-coded variable names, so like 132, and Rasta even says in his thing, try changing, variable names. That didn't do it though. You need a little bit more finesse for it. So let's just go ahead and we're gonna name this 111111, and we're gonna name this. We're just gonna rename some variable names here, okay? Sometimes you have to chunk these up a bit. So you can also do things like, that is also valid syntax for all of these. So splitting up kernel 32, different ones like that are all valid syntaxes that you can kind of mess with as you're going along here. We need to redo load library. So I'll just name this LL, make it easy. And there's a load library right here I have to change then. And then we're also going to change address. I'll just name it AA. Let's change that here. Let's change that here. I'll take P, I'll make it PP, giggity. And then patch, we gotta change patch. I'll change this to testing. And that should do our variable names that we have to look for. Now what we need to do is kind of check on some of these. So you have AMSI, some common ones that are flag words is DLL, AMSI, and buffer, okay? So let's chunk these up just a little bit and see if we get around it. All right, let's try this. Hint, hint, it's not going to work. But I already know what happens. All right, notice here we still get blocked. This script contains malicious contents and blocked by antivirus vendor. So this detection is actually fairly more granular than the last one we just saw because they're not just specifically focusing on one specific area. So what can we do to break this up a little bit more to make it better? What can we inject into here to use this? Well, let's take a look at this. So we're calling AA here and AA's here. What happens if we just copy this whole string here and move this into AA? We need to get rid of that variable name there and remove AA completely. Let's try that. We have an argument issue, so I messed up on my code, so give me a second. Actually, hang on, I messed it up. Yeah, hang on a second. Sorry. Look at we're in AA, we're going into LL here. I got these backwards. So let's move this back here. Let's use this here. And again, get rid of that variable. So we no longer have LL anywhere anymore because AA was being used down here as well, so that wouldn't have worked. We could chunk that up by moving AA down to here and to here, but LL is a little bit easier. So instead of doing that, let's just redo this a little bit, make it a little bit smaller, which is nice from an efficiency perspective. Clean the code up a little bit, make it look a little pretty, put some comments in here, and then we'll go ahead and run this, okay? Notice here, we now get true. So that means we successfully got around AMSI, and now we have full access to getting around that. So let's go to a brand new process. Let's go to a brand new process that we can execute this on. Notice that it's true. So now if we run anything in this process space from our specific commands, it is now going to not be submitted directly to AMSI. We have rewritten this specific application to get around directly get around AMSI in the first place. So again, easier ways to get things done. So that was really the big area there. Again, rewriting, going through it, it's usually pretty trivial to get around and kind of manipulate. Let me show you the new version of Unicorn that's coming out today after this talk, and then I'll answer any questions that anybody has because we have about 10 minutes left. So the new version of Unicorn, as I mentioned before, is going to have all this built into it. And by default, if you go into unicorn.py, you can see on here now that by default, the AMSI bypass is going to be on by default. Now again, if you just want to get to the code without all the obfuscation in place with the Unicode and base64 encoding, you can just turn print decoded to on, and it will output all the code directly for you in the first place. So that's one piece there that you can use directly. But this is going to have AMSI bypass on. We're going to go ahead and run Unicorn. Oops, forgot to, what did I do? I forgot to give it the name. And so it'll generate the shellcode for us. Asking for the background of the smiley face. David on Twitter wrote that for us. He's got a link for it. I'll if you can ping me up on Twitter, I'll get you the link for that background. There's a whole bunch of great ones that he's done that have like cool smiley face backgrounds and a lot of neat ones. This is my favorite. Now notice here really fast when we generate this code with AMSI. So there's a 2191 character length restriction. I'm sorry, an 8191, not 2191. An 8191 character length restriction from the command line itself. What that means is that if you're coming from the command line itself, which I don't recommend, but when you run command.exe, the max character size that you can use is 8191. And so Unicorn's payload by itself, without the AMSI bypass, is sub 8191. It doesn't require, you can drop it in from the command line syntax. My recommendation would be to directly call it from PowerShell because the character strength length is substantially larger. You're not going to run into a character length restriction within PowerShell itself. So, just a heads up, this is the warning that you're getting here, basically saying that, hey, the length of the payload is above the line limit of 8191 if you're using command.exe. So the total length here is 11,809 with the additional AMSI bypass that's put into place. But it breaks up the different pieces of code for you so that you have the AMSI bypass first, and then you have the Unicorn attack itself happening second. So we'll go ahead and get that. And again, it's going to output if you look at this, it's going to output the RC file for us. So we have our RC file here that we can use. Now notice by default, I turn off a couple of things. I turn off auto verify session, I turn off auto system info, and I turn off auto load standard API. And the reason for that is if that an actual secondary or third type of protection against Meterpreter is that if you have standard APIs loaded when the second stage actually executes, it will trigger it immediately and say, hey, detection in place. However, if you wait a little bit and you load standard API after it's already been loaded in the second stage itself, it does not get detected in the first place. So when you first get your Meterpreter shell back, just type, load priv, load standard API, and you have the full-fledged functionality there at that point in time. The timing's off, and you're able to get through that specific detection itself. So that's the basically here, and then we go into our Unicorn code itself. Oops. And here we have both of our payloads, right? We have our AMSI bypass code, and then we also have our secondary stage, which is going to be our PowerShell code in the first place itself. So with that, that was pretty much it. I got 7 minutes left. I'll be happy to answer any questions in the chat room. If you're looking at, if you're in the Discord channel, go to the AMSI discussion live page. I am not looking on Twitch at the moment, so I won't be able to see questions in Twitch. But if you're in AMSI discussion live, I will be happy to answer any questions out there that you've done. Mubix is saying standard API won't be detected anymore or shouldn't be. It has been sense tested and doesn't get detected currently. That's great to hear. I did not know that. Perfect. I can remove that from there and test it. The question was, is this the same workflow as Cobalt Strike? Not necessarily. So with Cobalt Strike, the secondary stage, the actual payload itself from Cobalt Strike is not going to be detected. What may be detected, since Unicorn is a public tool, is what we saw initially during the AMSI detection, right? The pre-execution phase. So you may have to do some analysis initially to find out what the initial piece of AMSI is getting flagged on with Windows Defender and rewrite that specific piece there. Just, again, very easy to do once you know what to look for. So you might have to do that first. I usually try to keep up with it. I update Unicorn about once every couple weeks with the AMSI bypasses in there. So it just depends on when you want to do it or how you want to do it. But what I'd recommend is, take Unicorn and modify it for your own purposes and write your own obfuscated strings that are going to be different, and that will have a much longer shelf life for anything you have. I wrote a tool internally at TrustedSec called Sweetcorn, which is a fork of Unicorn that I rewrote portions of the sections there, and that has not been detected ever since I rewrote that specific piece there. So you have a much longer shelf life by just modifying your own and changing your own and knowing how to do that than using a tool that's off of the internet. And again, I try to keep up with it, but I get busy sometimes with certain things. But it's one of those things where you just kind of take a look at it and make your own stuff. It can be a little bit less or a little bit more valuable. I also will be I also recorded this session, so I will release this session afterwards for people to watch, so that I know I talk fast, and you could probably go back and learn some stuff again. So I did record this session for you as well. See, do we have any other questions? I think I said a question over here. Could you explain what type of bypass set item var? So with capitalizations and lower cases, people are looking at detections a different way. Usually when you see upper and lower cases being mixed, they're hoping for a detection that was written very poorly that's going to take not take into account uppercase or lower cases. So for example, things like encoded command, doing all caps, or abbreviating encoded command like -EC. Normally when you see the case variations, it's to throw off detection for poor detections that were made. And same thing for, you see the var being chunked up there. It's chunking up real names so that for things like keyword searches and detection, you can get around those. So it's just more ways of getting around, poor detections in most cases. For that. Another question was, will this work with EDR tools? So EDRs are a little bit different, right? EDRs are more so on the endpoint detection and response, right? So they're detecting more than anything else. And so when you look at the detection pieces of those, it really depends on what they're looking for in PowerShell. It does bypass some EDRs, but other EDRs look at things like length of command, the types of things like, does PowerShell have network communications? So there are different ways that you may want to obfuscate this or change it around to get around EDR products as well. It's just a matter of what it's detecting on. I can say that a number of my techniques get around EDR products very easily just by manipulating the way that they actually behave. So some EDRs, absolutely, yes, it does. Some EDRs, no, it will definitely bubble up and show as more of a unusual behavior for PowerShell. One of the things that an EDR product will typically flag on is the syswa64 downgrade attack, which PowerShell is being executed under a 64-bit process, then spawns a child process that is 32-bit. That's definitely an anomaly, and that's one thing that you can easily remove inside of Unicorn, to be able to go and do. Any other questions? Well, I think that's it for us. And, people are asking questions. I'll stick around for a little bit in the chat room and remove voice. Feel free to talk and hang out there. I'll be hanging out for a little while. Hop on our Discord. If you go to https:/discord.gg/trustedsec. We have a great community there. We're doing a lot of great stuff, a lot of great people. And I'll be unmuting the chat room here in just a second, where we can all kind of talk and go crazy and stuff like that. But thank you all very much. Appreciate it.